Salam Doctor, I'm SIAH YIH HOONG, and today I'm going to present my lab 3, which is generation of FM signal. So let's get into the first example. And this example requires us to plot a frequency modulation signal in time domain. As you can see that this is the code for the first example. And first of all, we need to declare all those variables, which is to declare the time interval, the amplitude for both carrier and modulating signal, the frequency for both carrier and modulating signal too. And after that, we need to declare the expression for the carrier signal, modulating signal, and the frequency modulation signal. For this carrier and modulating signal, they will be using the general expression for a wave, which is the sine wave and the cos wave. And for carrier signal, we choose to use cos wave, and then the modulating signal we use sine wave. As you can see that the carrier signal is equal to the amplitude of carrier signal multiplied by the cosine of 2 pi fct. And the modulating signal will have expression of the amplitude of modulating signal multiplied by the sine of the 2 pi fmt. So this fct and the fmt is equally to omega. And after that, we need to declare the frequency modulation signal expressions. For these expressions, we need to define the m by 2. This m means modulation index. And the expression for these signals is a bit special because it was derived from the formulas. And therefore, the formula is the amplitude of carrier signal multiplied by the cosine of 2 pi frequency of carrier signal multiplied by t and plus the m multiplied by sine and 2 pi fmt. And after that, we need to plot the three signals out. And I believe that I already showed how subplot works in the previous lab. And therefore, I will just skip this part. And we need to label our plot and the title also. And after that, we just need to run. So this is the graph, or this is the signal we get from those code. This is the modulating signal, this is the carrier signal, and this is the frequency modulated signal. And after that, we go for example 2. So example 2 requires us to plot frequency modulation signals in both time and frequency domain. Well, all of the things is working same, which we need to declare all those variables. Yeah, and here will be the n and the fs. The n is actually means that there will be 1024 points of vectors. The fs is the frequency. After that, we need to express or declare the expression for the signal, for the wave signal. And after that, we need to use FFT, which is the Fourier transform. So, and then we will just plot our graph out. As you can see that this is the graph. This is the time domain representation. This is the frequency domain representation. So for the last example, we need to plot the spectrums. So we need to declare all those variables, and then we need to declare the expression for the signal, and then we plot it out. And note that we still need to do something like this in order to get a more prettier graph. And then we will have the number of points. We will do the time vectors and sampling increments and the sampling increment and the sampling frequency. And then we will run our code. So this is the result from those code. And then we go into exercise 2. So exercise 2 requires us to create a vector time t that varies from 0 to 2 or 3 cycle with an interval 1 per 1000 or 1 per 5000. In this exercise, I've chose 0 to 3 and then 1 per 5000. And after that, we need to create a single sine frequency. And note that there is a requirement for us, which the frequency used in a message signal should be less than carrier frequency. And likewise, amplitude of message signal should be less than carrier. amplitude. And in this exercise, I've set my carrier amplitude as 10 and modulating amplitude by 5, which fulfilling the requirement given in the questions. And also, I've set my carrier frequency into 100 Hertz and the modulating frequency into 50 Hertz. And also both of these fulfill the requirement given, which the modulating signal should less than the carrier frequency. Frequency of modulating signal should less than carrier frequency, and the amplitude of modulating signal should less than the amplitude of carrier signal. And after that, we need to declare the expression for both wave. So Vm is indicating the modulating signal, and I've chose to use sine, and Vc is indicating the carrier wave, okay, carrier signal. I've chose to use cos. After that, we need to declare the modulation index. So in question given, they told us to use a modulation index greater than 1, and therefore I've chose to use 2. After that, we need to generate an expression for our FM signal, which the frequency modulated signal. And this expressions or formula is coming from the node given. So after that, we need to plot all these three signals. Yep, and giving it their labels, their title, then run. Oops. Okay, so this is the result coming out. 0 from 0.3 and cycle. Okay. After that, let us get into exercise 3. So exercise 3 has already gave us the message signal and the modulations and the modulated carrier signals. So we need to use this signal to illustrate the single-sided amplitude spectrum of the above. First of all, we need to declare our sampling frequency and then declare our sampling increment. Then after that, we need to set the points as 1024, which means that we will have 1024 points across the graphs. So after that, we need to make some expressions for the modulated carriers and amplitude spectrums, and then we will just plot our graph, run it. So this is the spectrums from the code. So this is all my presentations, and thanks for patience on listening to my presentation. Thanks.